minimize coupling, that is interdependence of each module on each others, and it should provide value to all stakeholders. And ultimate aim is, because we have want that it should be understandable, so it should be very simple to, and it should be understandable to the everybody. So we have to keep it as simple as possible. So in the models, the first thing we start with the context models. So context models actually defines what is inside the boundary of a software and what is outside. So which entities are part of your software and which entities are actually outside the softwares. So we also take care of other softwares around it. We also take care of social and organizational factors. So finally we prepare the architectural model out of this, and which describe the relationship between the different systems which are to be used along with your software. So like a context model of an ATM is, we have ATM system, so some security system which is outside it, branch accounting system for a particular bank which may be giving input to this, branch counter system which may be giving input, some maintenance system, that how it has to be maintained, some usage database, or some customer account database. So these things are coming from outside, and then you have to make a ATM software which is taking input from all these softwares. So we cannot change these softwares, we have to take input from these softwares, and then we have to implement the functionalities given in the requirements. So after setting the context, we can see that this is the actually analysis model graphical view. So we have to prepare three kind of diagrams: ER diagrams describing each entity of a system, data flow diagram describing each process and specification of it, and the state transition diagram which gives us the control specification of systems. Along with each diagram, so we have to provide the data dictionary. So what is a data dictionary? So it is used because we may be using different terms, abbreviation while developing a software. So we have to describe each term, each data types inside our systems. So usual contents are like name of an entity, aliases, where and how it is used, the description of that entity, and any other supplementary information or constraints associated with it. Now most of the times we use the tools, because it may be possible that if you are using normal using the data dictionary in Excel or Word, so there may be, you may enter the duplicate values, duplicate entries. So we use the tools to prevent any duplicate names, to enforce any naming conventions. We can easily print out. We determine the range of impact of changes if we make changes, so how many entities would be impacted, and it also helps us in the software configuration management. Now in the process models, so it shows the overall processes, the different functionalities of your softwares, so which are spotted by your system. So data flow models may be used to show the processes, and the flow of information from one process to another is shown. In the data flow models, so it is, we mainly use the data flow diagrams, so which are basically actually describe the different processes in the systems and the flow of information from one process to another process. So these shows a processing step as well as a flow of data. So these are the intrinsic part of all the analysis methods, whether it is object oriented or structure design. We need the data flow diagrams. These need to be very simple and intuitive, so that the customer can also understand this. We should not add complexity to this. We may have to develop these in a hierarchical manner, so that the different level of user can understand it. And finally, it is meant for end-to-end processing of a data, which means from where data is coming and from where data is going, we need to mention it. So it is a pictorial representation. It is not like a flow chart. So we are not giving any control information. We are not providing any logical information. So we are only providing information at a different abstraction and the flow of information. So basically, it always starts with the level 0 diagram, which is called the context diagram. So let's say whatever software that you are developing is in this ellipse, you define the external entities from where input is coming on one side, and other external entity from where the output is going on one side. So this is actually the first diagram, which is easily understandable by the different customers, so they can understand that from where information is coming and where it is going. Now we can further elaborate this in the level 1 diagram. So we use these notations, like the rectangular box is used for external entity, your all functionalities are in a elliptical box, your arrowhead represents the information flow and the information type is written on it, and open ended rectangle which is open from two sides represent the actual data store for where you will keep your information. So we start with example like this is the process name, and these arrow represents the different information coming, and the type of information is written, and this arrow represents the output is going. So to create a data flow diagrams, we first start with the level 0 where only one process is there. We depict single bubble, show primary input outputs, then we hierarchically create other diagrams. We identify process, data objects, data stores, and label all arrows, and we refine one bubble at a time. For example, let's say we want to develop a software which tracks the safety of a particular house. So it has one control panel from where the user command is coming, some sensor like temperature or heat sensor from where the information is coming, and it is displaying output on control panel. It is raising alarm or it may call a telephone line. So these are the three outputs. Now in these diagrams, in the first diagram we can understand from where input is coming and from where output is going. Now we can elaborate it in the second diagram. To refine it, we have to describe each bubble. So we have like in the control panel we can say that what kind of input is coming, what kind of sensors events are there. So we can accordingly further describe it. Like this diagram, now to understand this complex diagrams. So what it is doing, it is we have one input box which is taking input from user, one input which is taking input from sensor. So after taking input, this bubble is either processing password or validating the user. This bubble is activating or deactivating system, and this bubble is for configuring the system. After configuration, we are storing the configuration data in the data store. This bubble is meant to display output. So after level 0, what we have done is we have two bubbles for input and one bubble for output, and these three bubbles are for processing functionalities. So these diagrams are easy to create because we have to identify input bubbles, output bubbles, and the bubbles which are used for implementing a functionalities. So in this way the first level diagram is created. From this diagram, let's say you want to elaborate further, you want to say that this particular bubble is not understandable. So you can elaborate it in a second level diagram. So that particular bubble, the bubble shown here, now it is elaborated in the level 2 diagrams. So this particular bubble monitor sensor is elaborated. So it is taking one input from sensor, one from this data store, and giving three output. Now when it is elaborated, again it is taking one input from sensor, one from data store, it is reading sensor, assessing against sensor, one bubble for to display sensor information, one for alarm, and one for dialing. Again three bubble for output, one for input, and one inside functionality. So in this way we can keep on elaborating the data flow diagrams. So the number of levels depends upon the kind of particular software developed. So we increase the number of levels just for having a more level of details. Similar to the data flow diagrams, another kind of diagrams are the decision trees. These are also gives us the graphical view of the process logic involved in the decision making and the corresponding actions taken. So edges of the decision tree represents conditions, and the leaf node represents the action to be performed depending upon the outcome of the testing the conditions. For example, in a library management systems, we can have the three options. Either we can go with the new members or renewal of member, or we can cancel the membership. So we can have this kind of decision tree where user output is coming, and from user we are taking this, and it can go into the 4 directions. So in the one direction, whether the selection is valid, we can either create a new member, or we can renew the membership of somebody, or we can cancel the membership. In case of invalid option, we have to display the error message. So for one particular input, we have to say that what are the possibilities further for that particular input. That input is, if it is not valid, we display error message. If it is valid, what are the things that we can perform. So this is the idea which is given by the decision tree, and again it is very easily understandable by the users. Another form of representation of requirement is using the decision tables. So decision tables are used to represent the complex processing logic, so which are sometimes not easily understandable by the decision trees. The upper row of the table specify the variables or the condition to be evaluated, and lower row represents the action to be taken. So a column in the table is a rule. So it can be understood with this particular diagram. So upper, this section, this represent the conditions, the lower section represent the actions. So if all the conditions, first condition is no, if there is no valid selection, we are not bothering about other conditions, then we have to take this action. Action name is display error message. If first two conditions are yes, if these are okay, these are true, and next two conditions are false, that is valid selection and new member, then we can take these actions. We can ask member details, we can build customer code, we can generate bills. So we can see that we are getting the name of the actions which we can take, but there is no the flow of action or the logic of action in the sequence in which it has to be taken. For that we have the sequence diagram. So along with that we can look at the sequence diagram to know that in which order these actions need to be taken. Similarly for other condition, for all the possibilities, we may have the multiple column of this table. Each column represent one possibility and the corresponding action to be taken in that particular possibilities. So we can see that the decision tables are also giving us a way to represent the different requirements. So we have seen that one is a decision tree in which we pictorially represent, decision tables where the number of condition can be more, actions can be more. So in that case, rather than having a cumbersome diagram of decision table, decision tree, we can go with the decision tables. So in these sections, today we have seen that the requirement analysis and the specification. So first we have specified the different requirements, and we know that we have to prepare the two documents, the user requirements and the system requirements. User requirement document is meant for the user, where we write in a way which is understandable to the users. We use the diagrams like data flow diagrams, decision trees, decision tables, and then we also can use the use case diagram and the sequence diagrams. So finally, with the help of these diagrams, the user can easily validate whatever we have written is correct or incorrect. So we may go through these steps again and again unless user validate each requirements. So once these requirements are validated, then we start our second document, which is the system requirements. Again we prepare the system requirement in a detailed fashion. Now this is not meant for user, this is meant for designers. So finally we prepare the system requirements, and these two documents further act as a basis for contract, and this document is further used for the designing. So next phase is the designing. So thanks, we have covered the requirement specification and analysis topic today. Thank you very much.